In this video, we are going to look at the Olympiad problem. Uh, this is in the form of a game. So let's try and understand this question. It is called the equation game. So basically, there are two persons who play this game, and they are using the equation x cube plus ax squared plus bx plus c equal to 0. This is my equation that they are using, right? Now, what is the game saying? You start with P, and P chooses any of A or B or C, and he can put a value for any of A or B or C, right? There are three unknown coefficients in this equation, A, B, and C. And P will start the game and he will assign a value to any one of those coefficients, right? He can say A is equal to 10. And then it is Q's turn, and Q can assign a value to any other coefficient, like it could be B or C. You cannot choose the same number that the previous person has chosen, right? So if P has chosen A and put a value for A, then Q will choose either B or C. And then finally, P can choose the remaining coefficient, right? So eventually they will take turns, and in three turns, basically what will happen is the whole equation will be set. A, B, and C will be assigned some values. Now the question is asking, or the question is stating actually, that P wins the game if the resulting equation has three distinct real roots. So no matter what Q and P choose, if the final equation has three distinct real roots, then P wins the game, right? The question is being asked is whether there is a winning strategy for P. What do I mean by a winning strategy? A winning strategy is there a way for P to choose his coefficients in such a way that no matter what Q does, he will always win, or the equation will always have three distinct real roots. Right? This question has appeared in Olympiads in the past, and it's a very interesting application of theory of equations. So it might even be useful for JEE, if not for PRMO and stuff, right? So just think about it, pause the video, and try to think about coming up with a winning strategy for P. Once I explain the solution, I think it will become super obvious. So please do take a moment, think about trying to construct a winning strategy for P. For example, I will show you how the game works. So P can decide A is equal to 2, right? So that means the equation has become x cubed plus 2x squared plus bx plus c. That was P's first turn, right? And then Q can decide, Q wants to ensure that the equation doesn't have three distinct real roots. So Q can decide B is equal to 100. Maybe make it very positive, right? So x cubed plus 2x squared plus 100x is now the equation. And then P can put any value of C. So maybe he put C is equal to minus 10 finally. So you get x cubed plus 2x squared plus 100x minus 10. Now the thing is, this equation that has come here, if it has three distinct real roots, P has one. And if it does not have three distinct real roots, Q has one, right? So basically, you can now check this equation. If you remember calculus, if you say f dash x here, the quadratic equation is 3x squared plus 4x plus 100. And I don't think this has any real roots. The discriminant of this quadratic is negative, so it has no real roots. So technically, P has lost this game. The quadratic has no real roots, so the cubic can at most have one real root because the quadratic is always increasing. Cubic can cut the x-axis only once, so P has at most one real root. So in this, the Q equation, so in this iteration of the game, P has lost. Right? So what we want to find out is if there is a strategy by which P can always win, no matter what Q does. Right? So think about it, and I will show you the solution in the next page. It's really interesting. So pause the video and try it yourself. I'll just explain the solution now. So the method by which you can figure out a way to always win is if step one, P chooses C equal to 1. So now the equation becomes what? X cubed plus ax squared plus bx plus 1 equal to 0. This is the equation. And let's say Q chooses some value for A, some value for A, right? I don't know what value Q has chosen. He could choose A, he could choose B, but he chooses some value for A, right? Then the third step is when P's turn comes again, P chooses B. P chooses B such that A plus B is equal to -3. Now you will understand why we are doing this. So no matter what Q chooses as A, let's say Q chooses A is equal to 10, then P will in the next step choose B is equal to -3 minus 10, so -13. Okay. Why do you do this A plus B is equal to -3? Because now what it will mean, first of all, because of C being 1, f of 0 is 1. If you call this as my f of x, right? F of 0 is 1. And now if you do f of 1, what P is trying to do here is to make the f of 1 term negative, right? F of 1 will be 1 plus A plus B plus 1, right? So if A plus B is -3, no matter what you choose, A is 10, B is -13. A plus B is -3, then -3 plus 2 is equal to -1, right? Basically, P is arranging things in such a way that f of 0 is 1 and f of 1 is -1. What does this mean? This means P is ensuring that there is a root between 0 and 1. Right? If the function, if a cubic is taking 0, f of 0 is 1, and then it will be coming f of 1 is -1, that means it has crossed the x-axis in between 0 and 1. This is a consequence of the intermediate value theorem that you might have heard in calculus. If f of x passes, or if x goes from A to B, then f of x, if it is a continuous and differential function, will always take all possible values between f of A and f of B. Right? So by that logic, you know that there is a root between 0 and 1 here, right? And you also notice that the function x cube plus ax square plus bx plus 1 equal to 0 and a plus b is equal to -3. This f of x tends to infinity as x tends to infinity, and f of x tends to -infinity as x tends to -infinity, right? We also have f of 0 is 1 and f of 1 is -1. Because of the way P played his game, P did C is equal to 1, and when Q chose A something, P chose B something as 3 minus A. Right? A plus B is equal to, no, not minus, not 3 minus A. A plus B was -3. So he said B should be -3 minus A. Because that will ensure that f of 1 will be 2 plus A plus B, which will be -1. Right? Correct. So now if you see the graph of the function here, f of 0 was 1. So function was somewhere here. And f of 1 was -1. So function has come down here. But we know that as x tends to infinity, function goes to infinity because the x cube term dominates. The function has to rise above positive here. And as x tends to -infinity, the function has to go towards -infinity because again x cube term dominates. Now we have three intervals, -infinity to 0, we have 0 to 1, and we have 1 to infinity, right? This point is the 1 point, and this is 0 point. There is one root here, somewhere in between, one root here, and one root here. In these three intervals, the sign of the function is changing, and f of x is a function which is continuous and differentiable. So it will definitely have roots between these three intervals. We don't know the location of the roots, but we are assured that there will be one root here. So that means there are three distinct real roots for the equation, right? Real roots. There are possibly other ways to find a winning strategy. You could find a winning strategy if you change the value of C. Your winning strategy will change slightly as long as you ensure that there is a root between f of 0 and some f of 1 or f of 2 and all. There are many other ways to do this, but this is a clear way to ensure that P always wins the game regardless, right? So I hope you have understood what we are doing here. And this problem was an actual Olympiad question. It was in the late 90s or something, and probably from a Greek Olympiad. I'm not sure exactly. Hopefully you will understand and enjoy the solution here, and we will see you in the next video. Please like and subscribe to the channel, and I'll bring you more content related to Olympiads and JEE soon. See you in the next video.